That's a pretty functional game right there, but as usual, we'd like to add some kind of nice finishing touches. So the two things I'd like to add, I'm going to show you some particle effects. Maybe when you hit the star, you get a burst of sparkles as the star explodes. And then I'm also going to show you how to graph the paths that the shots follow, which will help you with aiming in the future. All right, first, a particle effect. I'm going to right-click and create a particle system. Particle systems are awesome. They can be used to simulate all sorts of things, fire, water, very good for kind of natural or magical phenomena. I'm going to rename this to Sparkle, because I'd like it to look like some sparkles. And basically there's just like 100 properties which you can change. My burst of sparkles is going to be short. So I'd like the duration to be half a second, changing duration to 0.5, and it doesn't loop, it just happens once. Let's see. The particles, I only want the particles to last for a single second, so I'm going to change their start lifetime to 1. Let's see, these other properties, I think they're fine. Maybe I'll do orange sparkles. So I'll click next to start color. Once again, pick nice orange. Let's see, what else could I set? Underneath emission, this tells you how many particles you're getting a second. I'd like a big burst of particles, so I'm going to change that to 1,000. Go ahead and emit 1,000 per second. And if you want to preview at any point, while this is selected, the particle effect window, I could hit stop and then simulate. And that gives me a burst in kind of a cone-like pattern. I'd like something different. So I'm going to change the shape. So clicking next to shape, it expands this. Right now it's set to a cone. I'd like to change that to a sphere. Hit stop and simulate. That looks pretty neat. Right. One thing I can change, just again, if you play with a particle engine, you'll see you can accomplish so many great effects. One thing I'd like to do is I'd like the particles, it looks like they just kind of disappear, like they're just running into a boundary. What I'd like to do is make the particles shrink over time. To accomplish that, you can go down in this list. One of the options is size over lifetime. It's off by default, but I can click next to it to turn it on. And then clicking to the right, after it's checked, there's a little graph you can adjust which will indicate how the particle size changes over time. So if I click next to size, there's a bunch of kind of preset options you can look at. I'm going to click on this line going down. Notice the graph of this red line changes. That means the particles start at 100% size, and then as time goes by, their size shrinks to 0. To see what this looks like, it looks like they're just kind of getting smaller over time. I think that looks pretty good. All right. Let's see, I'll set the default position to 0, 0, 0. I want this to be a prefab. I want this to spawn at the right time, so I'm going to go ahead and click and drag this down here. Create a sparkle prefab, and then I'll go ahead and delete the one which is on the screen. Then I can instantiate this later when I need to. All right, let's set up that part of the code where we create the sparkle effect. That's going to be managed by the goal script. So going up to the goal class, I'm going to create another public variable, game object. I'll call it prefab effect. And then, basically, whenever I hit the target, I want to create a prefab effect at that location. So the line of code where that happens is down here. If I collide with a ball, then I'm going to say game object, create a game object called effect. To do that, I'm going to instantiate prefab effect as a game object. And then I need to move it to the right position. So effect.transform.position is going to be equal to, well, wherever the star is located, the object attached to this script. So now, to get these 2 new lines of code in, go ahead and save. Head back to Unity. Give this a try. Oh, didn't work. There's an error message here. I forget to set prefab effect. Sometimes I get very excited and forget to set all of those variables. So clicking on my star, it's waiting for, what's your prefab effect? I'll drag sparkle all over. Now let's give it a try. There we go. Very satisfying burst of sparkles, and I win. Alright, the last thing I'd like to do, if you have a very challenging level, you might notice that it's kind of hard to precisely or properly aim things. So it's nice to give your user some visual assistance. So in order to do that, we're just going to create a line which kind of follows the path of the ball. To do this, the first step is to go to the hierarchy and right-click and create an object, an empty object. I'm going to name it path. It's going to be kind of a curve that follows the target ball. All right, attached to this, I'm going to add a component. This is actually underneath effects, something called the line renderer. It can be used to draw lines. That sounds like a useful thing. In path, I'm going to start that at 0, 0, 0. All right, there's all sorts of properties we can set. One of the most important things is to pick the color of your path. To do that, I'm going to create a new material. So right-click, create material. I'll call it mat_path. In this case, just a single colored line would be sufficient. So in the box next to albedo, I'll click. Maybe I'll make it like a red color. That would be fine. And now we'll go back to the path object in the hierarchy. I need to expand the materials tab where it says element 0 and it's looking for a material. I'm going to go ahead and drag that right up. Other things, I do not need to use light probes. I can check that off. And parameters, I don't want the path to be too thick. So the width is going to be a little bit smaller. I'm going to change the start width and the end width to 0.1. So expand the parameters and go ahead and change those. All right. And as always, I'll keep my assets panel organized. Okay, so I've got path. That's set. But what I need now is a script to control it, to tell it, hey, here's how you draw a path. So in the assets panel, I'm going to create a new C# script. This will be our last one for this project. It'll be called pathmaker. So go ahead, create that. Double click. And so this is what's going to be attached to our line renderer to tell it what to do. Now it needs some information here. Let's see. It needs to, for instance, keep track of its line renderer. So I'll create a private float, not float, a private line renderer called path. And then it's got to keep track of what it's tracking. So I'm going to create a private game object called target object. The script will be able to set it itself. Also, I don't want to keep drawing points like at a very small resolution which the user can't see. I don't want to waste memory. So I'm going to store all the different points I need to graph my path, but I'm going to say I only need to graph 2 points once they're a distance of 0.1 units apart. So to store this information, I'm going to create a private float variable called min_distance 0.1f. This is, again, it's the space between points in the path. If this was a large value, it would look like a lot of long, straight lines with sharp corners. The smaller this number is, the smoother your path will be. but if the number is ridiculously small, it just eats up memory. Finally, I need to store the points in the path. So I'm going to create, not an array list. I'm going to create just a list. So I need to do another import statement. Using, let's see, system.collections. Array lists are cool, but I'm just going to do a generic kind of list. So I'm going to also say system collections generic. I'd like to use that as well. And then create just a list of vector3 objects. I'll call it point list. It's going to store the different points on the path. All right. So let's see. I should probably also say, what is it that you're trying to follow? Or at least who contains the target object which you are following. So let me also set up a public game object called follower. And this is going to be whichever object is the camera which is tracking the ball. And I'll set that manually later. All right, in the start method, I'm going to initialize some of these variables. So I'll say the path, for instance. The path is, I'll take a look at this object, then get component, get the line renderer, which is attached to this object. Let's see, when the game starts, I can't see the path right away, so I'll set path enabled to false. Let's see, point list is a data structure. I need to go ahead and initialize that. Point list equals new list containing vector3 objects. All right, now I need to go ahead and set up my update. I'd like to update at the same rate as physics, so I'll change this to fixed update, and I'll write some code. First, I need to figure out what is it that I'm following. Right, so follower refers to the game object, and I need to go into that game object, get the follow target script, and see what the current target object is. So I store a copy of that in this class. So this target object, along whose path I'm drawing a line, I'm going to say follower dot get component. Right, the camera has a follow target script attached to it. And attached to that script is a target object, which may be null if it's not currently following anything. And if that's the case, if the target object is currently null, there is nothing to do. So I'll just say return. Otherwise, there's a lot to do. Right? What I need to do is I need to figure out where the current target object is, and possibly add this point to a line to be rendered. All right, so what I do next, now at this point, I'm going to say, first, figure out where my current object is. So vector3 current point is equal to target object dot transform dot position. All right, now I want to see if I should add this current point to my path. If the current point is really, really close to the previous point, I don't really need to add it. I only need to add a new point if the ball has moved a minimum distance. In this case, the minimum distance is 0.1. But none of that matters if it's the first point. So if pointlist.count is greater than 0, right, as long as this is not the first point that's being added, I'm going to extract the previous point, the position of the previous point, and that's why I'm using this list structure, point list, and then get the last element in the list, pointlist.count minus 1. Right, this is the position of the last element in point list. Then what I want to do is check to see if previous point is far away from current point. And if it's not, then don't bother graphing it. Right, so there's a big if statement. If current point dot previous point, right, that gives me a vector, and I want to check how long it is. That tells me how far apart these points are. So if its magnitude is less than the minimum distance, then what am I going to do? I'm just going to return. Right? It's not far away, it's less than minimum distance, don't bother graphing it. Right. So otherwise, right, what am I going to do? I'm going to add, right, if it passes all these tests, if it gets to this point in the code, it's worthy of being graphed, either because it's the first point or because it's far away. So at this point in the code, I'm going to add the current point to the list. I want the path to be visible, so path.enabled should be equal to true. Path.setVertexCount, I need to tell the path how many vertices are on it. The number of vertices on the path is the same thing as the size, or the count, of the list. And the next thing we need to do is to set the current position of the path. Path.setPosition. It's going to be point list size -1. And current point. Right, so this places current point in the path in the line renderer at this position. All right, this sounds pretty good so far. And so that's all set up. And so pathmaker, I need to attach that code to path. Right? And I've also got to set this variable follower. Who's the follower? It's the main camera. So path. And so this way you can extract information from that object. All right, let's give this a try. See if we remembered everything. All right, cool. We've got a red line, and it tells us where the ball went. Then we go back. The next thing you might notice that you might want to do is, I can use this for aiming. Right? So if I let it go, then it's going to go above this path. If I let it go over here, it'll go below. But I've got lots of red lines cluttering the screen. So the next thing I'd like to do is add a script which is going to clear this stuff out. Or not add a brand new script, but add to this current script. So I'm going to create another method. This is going to be a public method, so other classes can call it. This method is public void clear. Basically what it does is it sets up that there's no more target object. So target object gets set to null. Path.enabled is set to false. And I can no longer see the path. And the point list is now cleared. Right, rather than reinitialize it, I can just clear it out. Right. So I've got this public method right here. Now I need to be able to call it at the right time. Well, what's the right time to call this method? And the answer is the slingshot class. Right? Whenever I release the button, then slingshot should clear the current path, and then pathmaker will always monitor follow target and determine if there's something new to be drawn. So what I need to do is go back to slingshot. What I'll do here is make another public game object. I'll call it path. And then down here, again, when I release the mouse button, so this is at the bottom of the class, there's one more thing I need to do, and that's path.getComponent. Remember, I need to get the component attached to the path object. So I'm getting the pathmaker class. And then I'm going to run its clear method. Go ahead and save that, and save this. Got to make sure everything is saved. And it says right now, what is pathmaker? Don't worry, pathmaker is another class. Alright, so got my slingshot. It wants to know what path is. So I'm going to drag path over here. Then save and give this a try. And so we already know that the line renders pretty nicely. So when I click, when I release, it should clear the previous path, and now we just see the current path. Alright, that looks pretty good. We've got a functional game. It's got some extra special effects, some things to indicate where the player's going. The player will appreciate that. And that's it. Hope you enjoyed the tutorial, and good luck on all your Unity projects.